Can you hear me? Right. Hello, everybody. How are you doing? Feeling good? Awesome. We hope you are having a great time at this amazing conference with such fantastic speakers, excluding us. Thanks for joining our presentation. Both of us are very excited to be here today and to share some cool stuff with you. But before we start, please allow us to introduce ourselves.
Okay.
This is
hello.
George.
Yes, and this is Panos.
George, you want to tell us a few things about yourself?
Of course. I'm George Romanas. I've been in the testing field since 2008. I am a software engineer in test and also an active organizer in Ministry of Testing Athens community. Panos?
And I'm Panos Megremis. I've been working in the testing field for more than 10 years with experience spanning multiple industries from mobile marketing to lotteries. All right, enough about us. Ready to crack on. George, why are we here today?
We are here to tell you a story.
Story, okay. What kind of story?
A story about a challenging project we started working on a few years ago, a project that tested not just our technical skills, but also our patience and coffee supply.
Coffee supply indeed. And as we share our journey, maybe you will find some similarities to your own experiences. This presentation is divided in 5 main chapters: the task, the challenge, the idea, the solution, and the step beyond. Let's start with the first one. To give you some context, we need to do some time traveling and go back to November 2021. In the middle of the COVID era, George and I are on the same team, and one day we got an email from our manager saying that there is a plan to build a game studio in-house, meaning we will develop games, and of course, we should test them. All right, good news, new business, new projects, new challenges. What do you think, George?
Games, whoa, I have never tested games before, and I always wonder how they are tested. Do we know what kind of games are we going to use?
I have no idea. Let me ask. Send a message to the manager, and the answer is to the games.
To the games, well, I know nothing about them. The only games I know are the ones that we played as kids on arcade cabins, and the ones that I play on my Xbox.
Right. I don't have an Xbox, and still I know nothing about the 2D games, so we are off to a great start. Right. To be more specific, the task is apply a test automation solution for 2D games. Let's think. What are the 3 cornerstones that we focus on when applying an automation solution?
Okay, first we have testability, how easy it is to test a game. A game with good testability allows testers to find bugs quickly.
All right, we have stability. We need to have well-structured tests that are stable and reliable, regardless of whether the tests run locally or in CI. They should not be flaky. To achieve this, we must implement a robust and solid solution.
Next, we have scalability, how well a testing framework can grow. A scalable testing framework allows test code to be reused, workflows to handle larger test cases, and automation to support new game features without major redesigns.
All right, okay. These are the cornerstones. Let's use them as our compass when we are going to start implementing our solution. Right, first things first. George, let's find what a 2D game is.
Okay, I will go to my coffee supply, grab a cup of coffee, and a 2D game is a type of video game where gameplay and visuals take place in a flat 2-dimensional space.
So we're having 2 axes, X and Y. X represents left and right horizontal, while Y represents up and down vertical. There is no depth involved, and this makes it simpler compared to the 3D games. So basically, we are talking about side-scrollers, puzzle, retro style, this type of games. All right.
Okay, now we know what the 2D game is. Do we know in which development framework are we going to implement those games?
Well, I don't know. Let me ask again. And the answer is Pixie.js.
Okay, I know the drill. So searching. Pixie.js is not a game engine. It is an API for interacting with web graphics library for high-performance graphics, a fast, lightweight 2D rendering engine for the web, commonly used for games, interactive content, and animations.
Right? Phaser and Unity frameworks are well known among the game developers. Unity has its own test automation framework, UTF. Who knows, maybe there is something similar for Pixie.js that will make our life easier.
Let's hope there is.
All right, so we've learned some things about what a 2D game is, about the frameworks, but George, honestly, I don't feel that we know much about these games. Do you think it's a good idea to ask for sending us a game and play around with it?
Let's play some games.
All right, so we've asked for a game, and here it is, the Gem Quest. Are we ready for our quest?
I can't wait.
All right, but before we start playing the game, let's move to chapter number 2, the challenge. Challenge equals problem. Let's find out together if there is a problem. George,
Okay.
could you please open the game?
Yes, of course. Sorry. Okay, here it is.
All right, so we have our game. It's running on a web server, right? I can see this fancy play button is animated. There is another button, settings. Let's click on it. We can turn on and turn off the sound. There is that info icon. All right, it has some instructions on how to play the game. We can go back and forth. All right, let's click the X button. And we have over here that image about the mobile showing that we have to switch from portrait to landscape. All right, let's click the play button.
Whoa.
All right, new screen. A lot of stuff over here. Too many elements. Too many things to cover. All right, let's take it step by step. Could you please refresh the page?
Yes, of course. Okay.
All right. I would propose to start by trying to locate the play button, George.
Okay, of course. I will right-click. Open the DevTools. Okay, I see some elements, canvas and some scripts. Okay.
Okay.
Let me try to locate the play button. Okay, I see nothing in DOM. Let's see for the settings button. Panos, I see only this canvas element and nothing else. It's weird.
Okay. George, where are they?
To be honest, my friend, I have no idea and I'm getting nervous.
All right. Me too. Seems tricky. We thought it was easy, but it is not. The story of our life. Let's take some time to digest what we've seen here. Let's take a deep breath and try to find what this canvas element is all about.
Okay, back to the search engine, and an HTML canvas element is used to draw graphics, animations, and image dynamically with JavaScript, provides a blank space called canvas for drawing shapes, text, and more, supports interactive 2D and 3D animations, ideal for game development, data visualization, and custom UI elements.
All right, so essentially what we've seen before, they are not elements. They are drawings and images within the canvas.
Exactly, even for text.
Okay, here's the plan. I propose to get some rest. Soon we should start looking for solutions. Many other engineers have likely faced the same issues, so there must be some good solutions out there that we can reuse for our case.
Okay, the following day.
All right, George, enough about the problems. Let's focus on solutions. While I was searching in forums, reading articles, and watching videos, I came up with the following solution. Let's try to break it down to understand the logic. So over here, we have a screen. It has a canvas, and we want to click the Let's Sit button. The idea is to visualize the working area and try to break it into sections. For example, if we divide the x-axis into 3 sections and do the same for the y, then we can find out in which block we should target to click the element.
Okay.
So if we go to over on X and to down on the Y, we are on the right spot.
Okay.
The code shows the math that we have to do to get the dimensions of the element. All right, first thoughts. It's working, something. It's working on different viewports since it relies on a formula instead of hard-coded pixels. But on the other hand, there are some challenges. What we have over here is much simpler compared to what we've seen for our games. Our games, they have many elements, so we have to make calculations for each of them. It's not going to be easy to maintain. And apart from that, I'm not so sure how stable the test will be, since some of the calculations may not accurately target the elements that we're going to interact with. Too much info for solution number 1. That's all. What about you?
Okay, I see that this solution is a little bit complicated, but it's a solution. Okay. I did also yesterday my research and came up with 2 tools, AirTest Project and SQLEX. Both tools use image recognition to identify and control GUI elements. SQLEX can be used with multiple languages, while AirTest Project only with Python. On the other hand, AirTest Project can support both mobile and desktop web applications, while SQLEX can support only desktop web applications. Okay, both tools seem promising, but again, we have some challenges here. In order to run in a CI tool, they need extensive setup. Also, they don't run test cases in parallel. Any thoughts on my concerns?
As you said, it's a solution, but probably doesn't seem the right one.
Yes.
Right? Okay. And of course, there is always the option to build something custom, right?
Yes.
Let's think about that and try to analyze it first.
Okay. At the top of my head, building a custom automation solution requires significant time and resources in order to design, develop, and test. We might think also of having a fully dedicated team in order to support and adapt the framework to the future changes.
Okay, all right, makes sense. I'm not a big fan of custom frameworks. Unlike the established tools, custom frameworks may deviate from what we consider as standard practices. And also, I'm wondering why no one has implemented for Pixie.js until now.
That's a really good point. Then we have compatibility. We might lack compatibility with CI tools or reporting aggregators, and we may face also cross-platform issues.
Okay, definitely we are going to have some onboarding challenges. The testers and the developers should learn the new framework, get familiar with that, and this might have a steeper learning curve comparing to the industry standard tools. All right, let's sum up. We have some solutions. Yes. None of them seems the ideal one. Let's keep looking. All right. I have that feeling that something good is going to happen. So, George, I got a message from you yesterday at 2 o'clock in the morning saying that you have some news. Is everything okay, mate?
Actually, I'm very excited. I couldn't sleep yesterday. I came to this article where Pixie becomes accessible. Once you tell Pixie that you want a container to be accessible, then Pixie takes care of everything else for you. How? By just adding 2 properties, accessible and accessible title, we are enabling the accessibility manager of Pixie.js. And let's see what this accessibility manager provides to us.
Yeah, let's take a look, please.
Okay. So back to the laptop. Let me open our example. Okay. So here is our example. I will do the drill. I will open the dev tools. As we can see, we have some scripts and also Canvas element and nothing else.
Yeah,
right?
That's right.
Okay.
Yeah.
So let's do what the article instructs. Sorry. I will press the tab button on our keyboard, and we see a div that is creating over here. Okay, let me do it once again. Okay. This is okay. So I will open it, and let's explore it. With a magical way, we see those elements being exposed, okay, as buttons. And let me perform a click. So As we can see, our element is highlighted. And also, the actual text changed from touch me to turn me on. Okay. So I will click the enter button to perform the click, and voila, we have our first click. How does this sound to you?
All right. Things are shaping well.
Okay. Do you think that we struck the golden vein here?
Let's see if we can refine that gold first.
Okay. Sorry, before we move on.
There is always that bad.
Yes, exactly.
Okay.
Actually, with this approach, only works on desktops, because only on desktop we have the keyboard logic. For mobile, we are not able to run it.
Okay.
Yeah.
Noted. It's something that we have to consider it.
Okay.
Let's go back to the presentation, please. All right. All right. So the whole idea about accessibility reminds me of what we have done in the previous project that we've worked on, a React Native mobile app. Over there, we were using accessibility IDs to identify the elements. So if we can follow the same logic, adding selectors based on accessibility properties, we might be paving the way for a solid solution, and this is exactly what we are looking for.
It seems that we are on track.
Okay, let's see.
Let's see.
Right. It's time slowly to move from theory to practice. So, George, what do we have here?
Okay, let's make some elements accessible. So, I was asking for a new game. It's called Catch Some Cash. And I was experimenting a little bit with the actual play button.
Okay.
So, in the actual code, I added two properties. The accessible needs to be flagged as true. And for the accessible title, I just put an identifier in order to differentiate from other elements that we might use in the future. And hopefully, we will see it in our game. And there it is. An HTML button and the test play button as our title attribute.
All right.
Okay.
All right. It looks like we're cruising along. We're cruising along until we've reached the point to say hello to Canvas. Metaphorically speaking, we rip it off, reveal the hidden elements, make them visible and accessible for interaction. So I think right now, George, we have this under control.
Let's see.
Right. Let's go to some standard stuff. What do we need to write a sim functional test?
Okay. First of all, we need to identify UI elements.
Right. Okay. Perform some actions.
Okay. And to verify the behavior of those elements.
Right. Straightforward. Okay. So let's think about what type of assertions we are looking for. Can go first, image comparison. We are talking about visual testing. We get a base screen, a screenshot, and use it as a base screen. Every time a test runs, we get the new screenshot and compare it with the base one and checks if there are any discrepancies. Most of the modern frameworks, they provide that functionality.
Yes. Then we have the optical character recognition one, OCR. We wanted a more sophisticated way in order to retrieve the actual text, as text is just an image.
That's a good point, right? Frames per second are really crucial for gaming for several reasons, impacting performance, responsiveness, overall experience. There should be an FPS threshold that we should not fall below.
Actually, I have never thought about this before. And last, we have animation. Games mean animation, so we need to verify that elements are animated.
All right, okay. Right. George, I think we've reached the point that we have to take some decisions. So let's see what we have so far. We found a way to identify the elements.
Okay.
We can interact with them.
Yes.
We made a list of what type of assertions we're looking for. Okay. Do we think that we have any blockers or impediments that would prevent us to not use, let's say, a WebDriver-based framework?
Let me think for a sec. I don't see any drawbacks.
Right. In that case, we should stick with a stack that we have used in the past. We know that works well, and we trust it. And here it is. WebDriver IO is going to be the browser automation tool. Mockup the test runner. Selenium Grid will handle the test parallel execution. And for CI, GitHub Actions. And this is exactly the same stack that we are using for testing web apps, right?
Indeed.
Right. Right. George, it's time to see some action.
Okay.
Let's run some tests.
Let me jump in our IDE. Okay. So here it is, but I don't want this one yet. Okay. So as we can see here, I just wrote one simple test that we will play a game from start till the end. Okay, we have used some standard practices like page object model. We have used this tab logic of the keyboard, and we have our assertions here, the OCR one.
Okay.
And last, we have our image comparison assertion.
Okay. I look at the code and I have some questions, George. Before we perform an action, I see that we tabbing to expose the elements in the DOM. Is that right?
That's true. Yeah, and this makes tests slower.
Okay. Sorry. This is going to be a thorny issue, and at some point we have to deal with that.
Okay.
Right? Let's run some tests.
Okay, let's run our test. Okay. I will open the Selenium Grid. Okay. Hopefully we will see the session here.
Yeah.
Okay, there it is. Okay.
Right. What do we have over here? We try to play that game. We see some tabbing to expose the elements. It's going to perform some clicks on the grids here and there, some animations. Something doesn't work. Okay, it's working right now. Okay. We see some clicking. All right. Sort of animations.
Do you think that we will win?
No chance.
Okay, I'm more optimistic.
Yeah.
Fingers
all right,
crossed.
Okay. 2 more to go. All right. 1 more. And here it is. All right. Okay. So we've run our first test. George, are we sure this is not a video?
Actually, I was prepared.
Okay.
Yes. And let's make the test fail. Back to the IDE. I will change our assertion from 6 picks left to 5 picks left.
All right.
And hopefully, we will see the test case fail. Sorry, I have to go back to Selenium. Okay.
Yeah.
It's one of those times that we pray for a test case to fail.
All right.
Okay.
Okay.
Seems faster.
Yeah.
Okay. Let me open the IDE. And here it is. We verified also that our assertions work as expected.
All right. Good. Good. Yeah. More than happy. Let's go back to the presentation, please. All right. So, George, all good. We have our first test running, but to be honest, too much code, my friend, for a simple test. Shall we try and make things simpler?
Definitely.
Right. So in that case, we can create some custom commands and matchers, and we can add them to a custom WebDriver IO service. The idea is to wrap all these extra steps, such as tabbing, hitting the enter for focus on the element, adding them to the corresponding methods, and then we will end up with by having some tests that will look simpler and more readable. Shall we take a look?
Of course.
At that example?
Okay. Here is the same test by just using the custom WebDriver IO service. As we can see here, we have used the iClick, the iMake accessible. We have our assertions and our new assertion, the matcher one. Okay.
All right.
One thing that I would like to point out here is that WebDriver IO provides you the ability of extending two objects, browser and element, in order to build your own service. So we used the browser one because, as you remember, elements are not exposed before we interact with the actual keyboard.
Yeah, okay, it makes sense. Let's go back to the presentation. Let's see where we are. Okay, right. So, we've seen that we can run a test locally. What about CI? We should be able to build the games, run the tests. Over here we have an example of a workflow running some functional tests. They are not many, less than 50. They run on every PR or merge into master. Over here we have another type of workflow. It's called exhaustive tests. It's worth mentioning that some games, they have hundreds or even thousands of different final outcomes, and we have to cover all of them, right? These tests, they run once, maximum twice, before the release. And that's large list of tests. We break them down in different runners, more than 200, as we can see over here. Each runner can support up to 5 Selenium grid sessions, depending on the hardware specs. So pushing test parallel to its limit. We want to emphasize about scalability, the ability to run few tests or even thousands of them. Right. George, there is always room for improvement.
Always.
Let's see how we can make things better. So, I was taking a look into one of our test reports, and I've seen that we have some flaky tests over there. There are some tests that they pass 3 out of 5, and some others, they pass locally, but they fail on CI. Yes. Do you think it's a good idea to do some digging and trying to understand what causes these issues?
Yes, actually, we dived into the matrix, and we have seen that the actual accessibility manager of Pixie.js doesn't work as expected for elements that are not rectangle. This means that when dealing with elements like circles, polygons, etc., the div that is created is not placed in the correct position in the canvas. Sorry. So we went with the workaround of interacting with the actual elements, and we hit the enter button on our keyboard, and this seems to be the cause of flakiness.
Okay, so we have a solution. We use sort of a workaround, but this somehow explains why we have this flaky test.
Exactly.
Okay, noted. Definitely we should pay some attention on these issues. Let's move on. All right. What about mobile, George?
Sorry to disappoint you again, Panos, but we are not able to run tests on mobile devices with the current accessibility manager of Pixie.js because it is enabled only when screen readers are enabled on mobiles, and we cannot interact with the actual screen readers.
Okay, it seems we have a long list of issues.
Yes.
I hope at some point we'll solve some of them.
Sorry for that.
All right. Okay, matchmaking. So let's recap. We have a solution, but it has certain issues. Flaky test, and we can run test on mobile. I think the key to solve these issues are hidden in the accessibility manager of Pixie.js. What do you think, George?
That's true. We did some pairing with the dev team, and we came up with the following approach. So first, we overrode the accessibility manager of Pixie.js to fix the miscalculations for non-rectangle elements. And second, we removed the logic of enabling the div when we interact with the keyboard, and we added in the games build. So in test build, we are always exposed those divs. In the production build, those divs are not exposed, and the game runs without them. This gives us also the ability of dropping off the custom WebDriver IO service and just use the built-in WebDriver IO commands.
Okay. No more custom commands. We go with the built-in, which is always go with the standard. All right, so what we have over here is our version of Accessibility Manager, where we can locate every single element within the canvas with high accuracy. All right. Let's see some code.
Okay, of course. Back to the ID. Okay, no, this one. Let's go to this one. Okay, sorry. Give me 1 sec. Okay, so here we have the method where we overrode the actual accessibility manager of Pixie.js. We have identified all the potential shapes that an element could be, like polygon, rectangle, circle, etc. We do some calculations over here, and at some point, we create the div with some attributes for testing purposes.
Okay, all right. Let's run some tests with the new version, George.
Yes.
To see how it looks like.
Yeah. Do you want to run one or more test cases?
Let's go with 2.
Okay. So here is our new game. As we can see, we use the actual same built-in commands of the WebDriver IO. And let's run it. Okay. Back to the Selenium grip. Okay.
Right.
Both they came. Okay.
Okay, cool.
So here is our test execution.
So
okay.
1, 2.
Let me check for the other one.
Right.
Here is the other one. And okay.
Okay, all right.
They seem faster.
Yeah. So, with a new version of Accessibility Manager, we end up with by having more stable tests and run faster.
Correct.
Okay. I think we're heading into the right direction. Okay. I'm going to ask you again. What about mobile, George?
Yes, actually, Appium is in the house.
Okay.
With the improvements done in the Accessibility Manager, we are able to run test cases on simulators, emulators, and real devices.
Okay. And here are some examples on how our tests running on real devices, simulators, so it takes some time. So as George said, we can run the test, real device, simulators on both operating systems, Android, iOS. They look stable, they look okay. Issue with the mobile solved. All right. New assertions. Okay, that sounds interesting. Let's see what new we can have over here.
Actually, a new feature that came lately is the use of web fonts instead of text in images. So we had an idea of dropping off the optical character recognition, OCR assertions, and just use the get value and get text built-in commands in order to retrieve the actual text.
Okay.
Next, we have the check sound. As you can imagine, sound is really crucial for the games and for the user experience. So we want to ensure that no sound drops will occur during gameplay.
All right. Let me get this straight. So we have the ability to write some tests that we can get the text from a button, something that we couldn't done before.
Correct.
And also we can write some tests where we can verify if the sound is on or off while we play the game.
Exactly.
Right. Good stuff. Metrics. Let's see what we've done so far. So this project is running for almost 4 years. Around 100 games into productions, more than 35,000 test cases. We have functional tests, exhausting tests, tests that run on mobile, iframe, end-to-end against Unreal backend. Right. But we have to be honest, George. There are some things in the game world that cannot be fully automated. For example, testing the actual sound, evaluating complex animations, measuring the player engagement, assessing the look and feel. All this will require some human judgment at some point.
Yes.
Right? Okay. Before I go with the final slide, a shout out to one of our colleagues, Chris for his valuable contribution and guidance in our solution. Okay, community. Frankly speaking, we didn't reinvent the wheel, did any rocket science, or send a man to the moon. All we did was searching, use the experience that we've gained from previous projects, and of course, standing on the shoulders of giants. And by that, I mean all the incredible people that have built this community and created so many useful tools and frameworks that most of us rely on. So this presentation is dedicated to them. Thank you, George.
Thank you, Panos. Thank you all.
Wow, that was a show, isn't it? How many of you liked a very refreshing conversation-style talk? There you go. That was George and Thanos. So not Thanos, Panos. I was just fucking around. For ripping off the canvas and making it testable. We have, can take a few questions. There you go.
Hey, that was very interesting. Thank you. I was wondering if you considered to push your changes or your improvements back to
Yes,
Pixie.js.
actually, we have already thought about this, and we are. We need to communicate a little bit with the Pixie.js in order to have a conversation with them, but we definitely have that in the mind because, as we said, we rely on community. We want to offer also back to community.
Any more questions?
Hello. First of all, great presentation. I would like to ask you regarding the third solution. How much time did it take you to make it happen?
Okay, around 1 week for a POC and like a sprint to come up with a final version and see that instead of going with something custom or a tool that is not, WebDriver based, so like in 1 full month, we have already a ready solution for testing a game, something like that.
Yes, the first solution, the one with the tabbing, etc. Yeah.
Any more questions? Can take 2 more questions.
Okay.
All right then. Thank you, John.
Thank you very much,
Panos.
guys.